All right, so let's look at number 20. It says, in the setting of exercise 19, let theta be the angle that the line through the radar station and the plane makes with the horizontal. How fast is theta changing 12 minutes after the plane passes over the radar station? Okay, well, in order to get some context, we do need to go back and read number 19 again. But if you remember 19 from yesterday, it says, at a given moment, a plane passes directly above a radar station at an altitude of 6 kilometers. So I'm just going to put a dot here for my radar station. And then 6 kilometers or kilometers, however you want to say it, an airplane passes over. And then we also read in part A of number 19 that the plane's speed is 800 kilometers per hour, okay? So I just want to get some names here. What do you want to call this height right here? H, okay? Now what do you want to call this distance here? We'll call that X. Okay, and now since the airplane is traveling along X, right, that means that the airplane's speed is our change in X with respect to time. Okay, so it's 800 kilometers per hour. Okay, so that's the airplane's speed. And then if we go to number 20, it just gives us a little bit of new information. It says, let theta be the angle that the line through the radar station and the plane makes with the horizontal. So the line through the radar station and the airplane, okay? The angle that it makes with the horizontal, in other words, with the ground, is theta, okay? Is theta. But lucky for us, this angle right here and this angle up top are equal to one another, okay? Because if you're a keen observer here, you'll notice that the ground and the flight path of the airplane are two parallel lines. This line here that goes in between the two is what's called anybody know? A transversal. That's correct. And when you have two parallel lines cut by a transversal, then these alternate interior angles are equal to one another. So hopefully you paid attention in geometry and you knew that theta and theta, right? When it says interior, it means inside of the parallel lines, so inside the parallels. And alternate means on alternate sides of the transversal. So inside the parallel lines but on alternate sides of the transversal are these two angles that are equal to one another that we call theta. So for this problem, we're actually just going to use the one on the inside up there at the top. Is the only one that we really need. It'll just keep us from having to transfer everything to the bottom. Okay, we'll just use this top part that makes a triangle, and that'll make things nice and easy. Okay, so there is that angle theta. That's what they're calling it. Okay, and then it says, how fast is theta changing 12 minutes after the plane passes over the radar station? So 12 minutes later, how fast is theta changing? So what's it asking for? Yeah, it's asking for the change in theta with respect to time. So this is what we're looking for, the change in theta with respect to time. So if you look at what we have an H, we have a change in, we're looking for change in theta. We don't know theta. We do have a change in X. We don't know X. What's the other thing that's kind of missing from up here that I haven't written down yet? My change in height with respect to time. What's the change in height? Yeah, it's 0. So that's a nice one to have in there, that one is 0, right? But we do need to know theta, okay? We need to figure out what theta is. How can we figure out what theta is? Let me preface this. If we're going to find tangent, we need to get what first? Yeah, we need to find this adjacent side first, so we need to get X. So the way we're going to find theta is by first finding what X is. Now X, we don't have to do, it's some simple math in order to get X, because the airplane is traveling at 800 kilometers per hour, right? And this question is asking us about what's happening 12 minutes after the plane passed directly overhead. So 12 minutes after it was right there, how far had it gone? Well, it asks us about the time in minutes, right? So what we have to do is take this 800 kilometers per hour and get it into kilometers per minute, okay? So we'll take, since it's in hours, how do you divide an hour to get minutes? How many? Yeah, so we need to take this 800 kilometers per hour and divide it into 60 pieces in order to get how far we're going in a minute. So do 800 divided by 60, and you get 13.3, right? So that's how far it goes every minute. And then the question is asking us about 12 minutes later. So it's going to go that far 12 times, right? So 13.3 times 12. So 160. Okay, so that's what our x value is. That's how far it's traveled, is 60 kilometers. Okay, so now we want to find theta. Now, if we're looking for this angle theta right here, this is what we know. We know about the opposite side, and we know about the adjacent side. So what does that mean we're going to use? Tangent. Very good. So the tangent of theta, because tangent is opposite over adjacent, will be equal to 6 over, 6 is the opposite side, over 160 is the adjacent side. So 6 over 160. And now how do I get theta by itself since it's inside of a tangent? Very good. We have to take a tangent inverse in order to get rid of tangent. So these cancel, and theta is equal to tangent inverse of 6 over 160. So you can actually put that into your calculator. So you want to go second tangent, and then just put in 6 divided by 160. And what do you get for theta? 0.037. Everybody get the same thing? 0.037. All right, cool. So now we know what theta is. So we know everything we could hope for. We have h, the change in h. We have theta. We're looking for the change in theta, but that's okay because that's our one variable, right? And then we know x, and we know the change in x. So now we just need a formula that's going to help us figure out what this thing is. Now, what formula ties all of those things together, or what equation ties all of those things together? Yeah, the tangent of theta. Remember, I said if there's something that, if you use some specific formula or equation in order to find one, right, then that's probably going to help you. It's going to be the one you end up needing to use in order to get your rates. Okay, so in this case, it is this same one. Tangent of theta is equal to the opposite side, which I'm just going to use the variables now, h over x. And the reason why I'm using the variables now, remember, is because we're actually going to find our rates, okay? So we're going to have to take a derivative, and we don't want to plug in before we take our derivative here. So let's take the derivative. What's the derivative of tangent? Theta. And then we need to have our change in theta with respect to time is equal to, now on this side, remember, we got to use a quotient rule, okay? So it's low, d high, minus high, that's h, d low, so that's the change in x with respect to time. All over low squared, so x squared. And now we're just going to plug in. So this is secant squared of, and we just found theta, right, is 0.037. We're looking for our change in theta, so I'm just going to write it down, change in theta with respect to time. And then over here, x, we get ready to plug in. What was x? What our size x? 160? 160 times change in h. What was the change in h? 0. Minus h, which was 6. And dx dt was 800, if I remember correctly, right? All over x squared. And remember, x was 160 squared. Okay. So actually go through right now and do secant squared of 0.037. So remember, you don't have secant on your calculator, but you can do 1 divided by cosine. That is secant. So 1 divided by the cosine of 0.037. Enter. And then square that number, and what do you get? It's 1. Yeah, you get 1. So 1 times the change in theta with respect to time is just, yeah, since that's a 1, we're going to use the, the multiplication property or identity property of multiplication. So, this thing just turned into a 1. So we could say 1 times d theta dt, or we could just leave it as a 1, right? Now over here on the right side, that stuff's just 0. And then we have negative 6 times 8, which would be negative 4,800. And then on bottom, what's 160 squared? Okay, so the change in theta with respect to time is equal to, so negative 4,800 divided by 25,600. Okay, and that makes sense, right? Because if the airplane's going out, when it passes directly over your head, you have to look way straight up in the air in order to keep up with it, right? But the farther it goes out, the angle that you have to look at begins to flatten out, right? So the angle is coming down, which is why we have a negative number right here, okay? It's negative 0.19 radians per minute. Okay? Other questions from the homework? 16? Sure. Let's look at number 16. A road perpendicular to a highway leads to a farmhouse located 2 kilometers away. See figure 8. An automobile travels past the farmhouse at a speed of 80 kilometers per hour. How fast is the distance between the automobile and the farmhouse increasing when the automobile is 6 kilometers past the intersection of the highway and the road? Okay, and they have a nice picture there for you, right? Up here, there's a little farmhouse. Okay, so we'll make a little farmhouse. And then there's a car traveling this way. And they told us that this distance right here between the intersection of the road and the farmhouse is 2. It says that the automobile is traveling, so it's moving at a rate of 80 kilometers per hour. And then the question is about whenever the car is 6 kilometers past the intersection. So when this car has gotten 6 kilometers past the intersection, that's what it's talking about. All right, so we need to name these variables, or these constants. What do you want to call this right here? Y. And you want to call this X. Okay, so the car's speed, since the car is going this way, what will we have to call the car's speed? Yeah, it's our change in X with respect to time. So it's a dx dt, and it's 80 kilometers per hour. 80 kilometers per hour. And then the question is about how fast the distance between the car and the house is changing. So how fast is the distance between the house and the car changing? I'm going to call that Z since we already have X and Y, right? So since we're asking about Z, right, what we're looking for is a change in Z with respect to time. That's what we're trying to figure out. All right, we know Y is 2. We know X is 6. So we kind of need to find Z, right? Yeah, we'll use Pythagorean theorem. That means that the 2 squared plus the 6 squared should equal Z squared. All right, and you guys are already hammering that one out already. What is it? 6.3. So Z is 6.3. Okay? Now, when you look up there, we have Y, we have X, we have our change in X, we have Z, and we're looking for dz dt. What's the only thing that's missing out of all of this? Yeah, my change in Y with respect to time. Now that's the distance between the intersection of the road and the farmhouse. Yeah, is the road moving away from the farmhouse? No, The road doesn't move, does it? It stays, just lays there. It's an inanimate object. It just sits there. And is the farmhouse moving farther down the road? Depends on where you live, right? It may be on wheels and it may move farther down. But no, the farmhouse is not moving. So that distance is not changing. So that means that dy dt is 0. And so now we're going to use the Pythagorean theorem to relate these three side lengths together. So it'll be y squared, I should actually do it this way, x squared plus y squared equals z squared. It's the last three letters of the alphabet instead of the first three. Right? All right, so take the derivative, and 2x times the change in x plus 2y times the change in y is equal to 2z times the change in z. Yeah, I can divide everything by 2, and all my 2's will cancel. So I have x times the change in x plus y times the change in y is equal to z times the change in z. All right, now I just want to plug in my values. X, if you remember, was 6, and the change in x was 80. Y was 2, and the change in y was 0. And then z was 6.3, and the change in z is what we're looking for. So I'm going to leave it as a variable. So these cancel. It's just a 0, so that's just going to go away. And 6 times 8 is 48. Add a 0. 6.3 dz dt. And now we just divide by 6.3 on both sides. And what do you get? Now z is a distance, which was measured in kilometers, and our time in this was measured in hours. We know that from the rate of the car. So it's kilometers per hour. Okay,